Okay, so hello everyone, can you hear me? Hello. Okay.
Yes, sir.
Okay.
Yes.
Okay. Okay. So basically today is our fourth number of class, and we try to discuss about the rest of the part who is not completed. Okay. So let's go over today's class. I should simply share my screen. Okay. So now can you see my screen? Okay, is it visible?
Yes, sir.
Okay.
Yes, sir.
Okay. So let's. Okay. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So basically today is our fourth number of class, and we try to discuss about this topic, how we can easily remove the cloud from the satellite imagery, and how we can easily work with the DEM data, mainly digital elevation model data, and then using this DEM data, how we can easily make the hillshade map, salt map, aspect map in Google Earth Engine platform. Okay, and different types of DEM data is available in Google Earth Engine platform. We can use and the same process, but I also try to show you the NASA SRTM 30-meter resolution DEM data. Then we also try to discuss about the land surface temperature monitoring using the MODIS satellite imagery, and also try to make the time series chart about that, and then calculated the average maximum minimum NDVI value for any specific region. Suppose when you want to calculate this type of calculation, how you can do it. Okay, so let's go about that class. So first of all, how to remove the cloud from the satellite imagery. So mainly in this time we are using here the cloud marks band. Okay, so every satellite image, it can be Landsat, Sentinel, has some other external band, cloud marks band. Okay, using this cloud marks band, we can easily remove all of those cloudy pixel value from the satellite images. So here you can see this is the one kind of satellite images. So in this satellite image, we find out some cloud or white pixel value. It means mention the cloud, but when I want to apply this cloud marks band function, then we can easily remove all of those cloud and we can get the very clear satellite images. Okay, so in this time we try to show you the practical example how it will be work, so then you can easily understand. So I simply open my code editor. Okay, so now I just try to show you this part for the Sentinel image and also show the Landsat image, both of image, how it will be work for the cloud mark band function, and also remove the cloud. Then you can easily understand about that. Okay, so let's go about the first of all, I try to show you it for Sentinel imagery. Okay, so for that I can simply search here, suppose Sentinel 2. So here I can get all of the, I want to work with the multi-spectral instrument level 1C. This satellite image I want to use in here this time. So in this time I need to just import this image collection in here. Okay, so after that, and after that it's showing the image collection default variable name. You can use any variable name. Suppose I put this name, suppose Sentinel 2. Okay, you can use any name. And now first of all I need to filter this image collection. Suppose I want to need this image collection for the Dhaka city region, so I simply import this shape file of this Dhaka city from here and put this default. I change the variable name and keep the variable name such as ROI, suppose ROI. Okay, so in this time I simply filtering my image collection. So take another variable, suppose image, and in this time I simply filtering this image collection. So I simply call the whole of image collection Sentinel 2, and I simply put here this filter according to my region. So put here the filter bounds function. Okay, and then put here this ROI. Okay, and now I want to use here the another function. Suppose I simply put here this filter filter date function and put this specific time code, suppose year of 2016, 1st January. Suppose I get the year of 2016, suppose December 31. I put this all of the year images. In this time, if you want, you can use a function filter metadata, okay, and put here all of those element arguments such as name, operator, and value. Okay, instead of the filter metadata, we can also use here the another function, but it also work as the filter metadata. Okay, same task will be done when I want to, instead of the filter metadata, it has the another function. This function is that we can also define the function. It's that filter. Simply use here the filter. Then how I can filter? I want to filter art engine filter dot, in this time, less than, lt, less than. Okay, so this is the same way when you want to work with the filter metadata and also work with this filter, then how I can filter less than. Okay, the same task will be done. Okay, if you want, I can also check it will be same or not. So I simply go to this image properties, suppose cloud pixel pattern, simply copy that and simply put here, and also set the operator less than, and set the value for 1, set the value for the 1. Okay, now I want to check how many images are available in here. Okay, how many image collection. So I simply print that and call this image and use here the size function and click the run. So now it's computing between the year of 2016 for my region of interest less than 1% cloud percentage, how many images are available. I can get the total 20 images. Okay, so in this time I want to check using this function how many images I want to got. Using the same function, in this time I simply commenting this line, so it's not executed. I simply copy this my image properties name and paste here and set the value 1. In this time it means that I filtered this image collection and put here the cloud pixel percentage lt means that less than 1. Okay, so in this time we can got the same result in here. You can see, simply click to the run, we can get the same result, 20 images. Okay, so if you want, you can use here the filter metadata and put all of the argument one by one, or if you want, you can simply use here the filter. Then how I can filter? I want to filter art engine filter less than, then put here this properties name and also set the value. Okay, same. Okay, so same, we can get the same result every time because this function tags and also this function tags is the same. Okay, so now I want to, suppose from the 20 images I want to create the median composite. So simply use at the dot median and also it clip with my shapefile. Suppose shapefile is that ROI. Okay, so now let's check about the display, and you can see when I want to make the median composite, so now I want to get only for the one image. Okay, so you can say I can get only for the one image. I simply print this image here, I can get only for the one image. Okay, so basically when you want to put the median function, then it nots a image collection. Okay, it create only for the one median images. Okay, so in this time I can get only for the one image. This image created from total 20 images median. Okay, so in this time I get only for the one image, and this image has the total 16 bands. Okay, so now I display this image. So map dot add layer and call this object image and click to the run, and also need to focus the center. Map dot center object is ROI and set the value, suppose 8, and click to the run. So I can got this image look like this. And now I want to set the display. I simply set the suppose color band before red, then green. I will set the for blue custom 98% spreads and then apply. In this time you can see I can get this image, but this image is the less than 1%, so that's why in this time we did not get the very cloudy image. Okay, but some place when you want to work you can got the some place, suppose river bank, or also you can get the coastal area. This type of region you did not find out the less than 1% cloud cover is not available. Okay, because this is a totally cloudy region. Then when you want to get this satellite images, then you have to increasing this value, then you can get the satellite image, because less than 1% is not available. So that's why you need to up to the 5%, 10%, 16%, 15%, and check for your region. Okay, so in this time suppose I want to increasing the value, suppose I put the value suppose 90%. Okay, and now check the result again. Okay, so I think some networking issue just. And I also set the band combination again and check the result. Okay, just a minute, I think some problem in the networking. I simply change the network. Okay, fine. Okay, select it. Now I simply add the suppose B4, then B3, and also put here the B2. Customize simply put suppose 98%, and then click to the apply. Okay, sorry for networking connectivity, so it takes some time for loading. Okay, so now you can see I can get this satellite image, but this satellite image we can find out some cloudy pixel value in here, and I also import that visualization and simply copy and then paste after the object name. Okay, and put this layer name suppose cloudy. Yes. Okay, so in this time you can see in this cloud image I can get some cloud. You can see this is the cloud, also this is the cloud pixel value, also I can get the some haze, you can see. Okay, also you can get the cloud in here. Okay, you can see cloud. Okay, so in this time I want to remove all of those cloud and all of those haze, so that I can get the very clear satellite images in here. Okay, using the same. In this time, I want to work with this cloud marks band function band. So you can check the cloud marks band information from here, from your information sheet in here. Go to the bands, and now we can check about the band. You can see the band QS60. QS60. So basically, it is a cloud marks band, and resolution is 60 meter. Okay, and cloud marks band has a some bit. Here you can see bits 0 to 9. It's totally unused. It's only use bit 10 and also use bit 11. And bit 10 has a signal 0 and 1. Also bit 11 has a signal 0 and 1. Okay, so 0 means that no clouds and 1 means that cloud present. Okay, also you can see cirrus. 0 signal means that no cloud, no cirrus cloud, or 1 means that cloud present. Okay, so in this time I want to use this band and then apply the bit 10 and bit 11. Okay, and then set the bit 10 equal to 0 and also set bit 11 equal to 0. So it's means that it identifies the clear condition of the satellite images. Okay, so in this time I want to apply a function. This function, first of all, I need to select this band. After that, I need to select the bit 10 and bit 11. From bit 10, I select the signal 0, and from the bit 11, I also select the signal 0. So it means that it is a totally clear condition of these images. And also you can check about this band. When you want to do the Landsat image, you can check the band. Cloud marks band name is the pixel QA. In this time, it is a QA60 for the Sentinel. And when you want to work the Landsat, it's called the pixel QA. So in this time, we try to work with that. Okay, so let's go about that. So in this time, first of all, I need to create a function. So this function, I need to select the QA60 band. And then from QA60, I need to select bit 10. And from the bit 10, I need to set equal to 0. And also need to select bit 11 and bit 11 equal to 0. Okay, so let's go. We write the function. So first of all, I take a variable name. Suppose marks to clouds. And then put here this function keyword. You can use this keyword and then put here the element name. So then put here the image element name. And then I put my argument. And all of argument I want to use this image. Okay, and now this image and this image is not same. Okay, so it's the element name, so I change the name, then it also better. I put the name, suppose img. Okay, it's not same, so I want to take an element name. So now I want to do all of those analysis, all of those argument I write using this element name. Okay, so first of all, I take a variable. Suppose I take a variable qa and then call this element name img and use here the select function and select this band QA60 band or cloud marks band. You can see this band QA60. Simply copy this band name and then paste here. Okay, okay, done. Then I also need to select the bit 10 and bit 11. Okay, so for that, I simply take a variable, suppose cloud bit marks, and when you want to select the bit marks, then we need to use the symbol 1 less than 10. Okay, this is the 1 bit I select. Also take the another, suppose cirrus bit marks. I take a variable and then put here this 1 less than 11. Okay, so I simply define this bit 10 and bit 11 in this variable. Okay, cloud bitmark and cirrus bitmarks. And now I need to select cloud bitmarks equal to 0 and also need to select cirrus bitmarks equal to 0. So for that, I simply take a variable, suppose marks variable. I take the variable, you can use any variable name, and then in this time I simply first of all call the QA, because QA 60, this is the band. In this band we can get the 2-bit 10 and 11. Okay, so I simply call the QA first, simply copy and paste, and then use a function. In this time I need to connect this image and then this bit I need to connect, so that's why I need to use a function bit wise and. What is that? Bitwise and. Okay, bitwise and then call this. Suppose first of all bit 10, I simply select the bit 10 and paste here, and then use here the equal 0. Okay, so one part is done. I said bit cloud bitmax equal to 0. It means that bit number 10 equal to 0, because cloud bitmax bit 10 is stored in this variable. Okay, and also do for the second part, I use here the AND function and also call the QA. This is my band. This band I need to connect with my Cirrus bitmax or bit 11. So use here the bitwise AND function and then put here this Cirrus bitmax. Simply copy and paste here. After that I simply select here equal to 0. So Cirrus bitmax equal to 0. Okay, so now I create my marks or create the new characteristics. So these new characteristics I need to add with my image. Okay, so I need to update my image properties. So in this time these properties I created. Okay, but these properties I want to use and update it. So for that I need to use the update marks function. Okay, so finally from this function I want to return this image update marks. So use the update marks function, and which properties you want to use for updating. I want to updating using this properties, so it will be set equal to bit cloud bitmax equal to 0 slash bitmax equal to 0, and all of the things stored in a variable, this variable. So I want to update this image according to these properties which I set in here. Okay, and all of those properties is stored in a variable. This variable name is the marks. Simply copy that and paste here. Okay, so this is the function. In this function we only work for the 2-bit, bit 10 and 11. When you want to work with the land set, then you can get the more bit. So bit 3, bit 4, bit 5, and there are the lot of different bit has stored the different types of pixel value. Suppose cloud shadow, cloud, okay, cloud water pixel. So this type of information we can store it the different types of bit. Okay, so in this sentinel we can got only for the 2-bit cloud and Cirrus, and get the 2 signal 0 and 1. 0 means that there is the no cloud, and 1 means that cloud is the present. So that's why in this time we can simply set equal to 0 signal and also set equal to 0. And finally we need to update this image with our properties which I set in here. So that's why I need to return this image update marks function, and which properties I want to use for updating these properties, and this property is already stored in a variable marks. That's why I simply use the marks. Okay, so now this is my function. Okay, so when I want to apply this function with my image collection apply here, then this type of cloud will be removed, and we can also all of the cells also will be removed. Okay, so let's go about that. Okay, so for that in this time I want to create the another image. Suppose I want to create the 2 layer. Suppose one layer showing the cloudy image and another layer is showing the cloud free image. Okay, then we can easily identify where is the cloud and now where is there is the no cloud. Okay, so let's go. I simply copy the same code and paste here. Suppose I put the variable name is that image 2, and then all of the things will be same. Okay, in this time in this collection I want to just add this function. Okay, so when I want to add this function with this collection, then it automatically remove the cloud. Okay, so for that I can simply use the function map function. So I simply use the map function and then call this function variable name. You can see, simply copy that and paste here. Okay, so now all of those things, all of those function added with my whole collection. Okay, so now I want to check the display result. Simply copy that and paste here. Okay, okay, then I also check the later after running this code. Click to the run. And also set this, suppose I want to put this, load it. Okay, load it. Okay, set the suppose a band 4. Also use at the band 3 and band 2. Custom 98% and apply, and also import that and simply copy and paste the after the object name I simply paste, and also put here this, suppose cloud free image. So now you can get the two layer you can see here, and also show the result about these two type of images. It's our cloudy image. I got it shot the black. I check the result. Okay, so it's not applying this reflectance range. Just a minute. I again import that. Okay, so 98%, and then apply, and then try to put at the import. Click the import, and after that simply copy and paste in after the object name. Yeah. And then click to the run again. So now you can get the result. So now you can see here. This type of white pixel value will be removed when I want to applying this cloud marks for the second image, this image. Okay, so you can see this is the cloud image, and when I want to and this is the cloud free image. You can see it will easily remove all of this cloud pixel and also remove all of the haze. You can see. Okay, so now you can easily use this cloud free image for your different types of remotely sense work, and you can easily get this result. Okay, so now any question you can ask me about that. Any question, anyone?
Sir, kindly do it for Landsat 5.
Yeah. So I also try to show you for the Landsat 5, Landsat 4 and Landsat 7. Already I developed the code. And this part I will cover when I want to talk about the land use land cover classification, because mainly we are when you want to make the land use land cover classification map, you must be remove the cloud. Okay, so that's why this part I also add with the land use land cover classification. Okay, so in this time if you want to try that, you can check it. I also try to show you this part. Suppose Landsat imagery also about the band, also their bit you can check from here. So Landsat, basically Landsat 457 is the same code for removing the cloud. Okay, and Landsat 8 and 9 is the different when you want to remove the cloud. Okay, so these two things I also try to show you this part. There is no problem. Suppose Landsat 8, and then you can see here the surface reflectance, and we can also get a band in here, pixel, QA pixel. Okay, this is the band, and basically it will be working according to this algorithm, CF max algorithm. So if you want to know about the more details, simply search the Google and also try to study about that, this algorithm, how it will be work. Then you can get the more information about. So in this time you can see the QA pixel, all of the bit you can see bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, okay, bit 6. Bit 6 has the 2 signal, cloud and cloud. Okay, also you can see bit 7, bit 8 to 9, cloud confidence. Okay, non, low, medium, high. Also you can see bit 10 to 11. Okay, cloud shadow confidence. Okay, in this time when you want to work with this same process, so you also try to that and face any problem. I also show you that when I want to work with the land use land cover classification using the surface reflectance satellite images, then I have show you that how can you remove the cloud from the Landsat 8, also 457. Okay, also you can see the bit 14 to 15 cirrus confidence. Okay, so in this time this is the bit and this is the signal, and how you can easily connect the bit and how you can easily set equal to 0 signal. Same process, we need to use that. The first of all select this band. In this time this band will be, you can see QA pixel. In this time we need to use the QA pixel band, and then we need to select the, take a variable name and set the bit number. Okay, and all of the bit number we can set same process. Suppose this bit number is the 10, but I need to use the 1 less than bit 10. Suppose you need to select the bit from here, you need to select the bit of suppose you want to select the bit of 10. Okay, then you need to select equal to suppose 0, signal 0. Same process, you can easily select the bit and also select the signal of 0. Okay, so same process you also try to do that, and you can get the cloudy image mainly river bank or coastal area, this type of region, also wet season, rainy season. But we are applying the same process for removing this type of cloud and also removing the haze from the satellite images. Okay, and I also show you this Landsat part for our next further class. I also try to discuss about that, but process is the same. Okay, suppose process is the same, you need to take a function, and when you want to add this function with your overall image collection, then it will be remove the cloud from your satellite images, so you can get the very clear satellite images from here. First time I can got this, and when I want to apply this function, I can got this type of image. Okay, so now you can easily work with this image for creating the NDVI, NDWI, or land use land cover, or any types of remote distance work you can easily do in here. Okay, so any question in part?
Sir, out of those two functions, which one is better?
Filter metadata and same.
Yeah.
Same. Okay, so basically there is the no, because we can get the same task. Okay, filter metadata and filter date is a similar function.
Okay.
If you want, you can use the filter this type. Also, if you want, you can also use the filter metadata, because in this time this less than, we need to use here the LT. Okay, and also set the value in here, and we can also need to set the in here. The same task, but the same function, you can use anyone. There is no problem. Okay, anyone any question? Okay, so you also try to do for your own region. First of all, you can take the cloudy image, then remove the cloud using this process. Okay, It is a one process, but there are a lot of process for removing the cloud. I also show you the easiest way. Okay, so let's go about that. Our next slide. So in this time, we try to discuss about the land surface temperature, how we can easily do that using the MODIS satellite imagery, as well as also Landsats and imagery. Okay, two types of satellite images, how we can easily use, and then try to make the land surface temperature monitoring, and also make the time series chart. Okay, so time series chart, previous class I also tried to show you the two types of time series chart. When you want to work with the product or which data is already available, then we don't need to create the band. Okay, but when you want to work with the satellite image, suppose in this time I want to create the Landsat image for creating this land surface temperature map. So that's why in this time when I want to make the time series chart, I need to apply the same process. First of all, I need to create the band of LST. Okay, then from this band we can easily make the time series chart. But in this time when I want to work with the MODIS has already created this band of LST. So in this time I use this band and create this map or time series chart. Okay, so let's go about that, how we can easily do that. So I simply open my code editor. Okay, so let's go. In this time I simply go to the data set. Suppose MODIS. First I try to show the MODIS, and here you can see we can get the two type of LST data. So first of all, you can see the land surface temperature. Mainly this is the global 1 kilometer. Okay, daily. Okay, suppose you want to observe the daily condition of the LST, then you can use the daily global data. Okay, also you can see another data set about that 8 day. Here you can see the 8 day. Okay, then we can get the data set every 8 days time interval. Okay, so same process when we apply the 8 day and daily. Okay, so when you want to make the time series chart also, then you can get the daily time series chart using this data set, and this data set you can get the time series chart as a 8 day time period. Okay, okay, so 100% is the more it also show the more reflectance, so that's why this result is not good. Okay, suppose it will be more strength of this reflectance. Okay, so that's why 98% is the better, and so that's why we are using the 98%. Okay, but when you want to use the 100%, it will be more strength. Okay, that's why we are not using that. Okay, but 100% is also okay, there is no problem. Basically this is the strength. It's mainly that which I want to show the satellite image better. Okay, and which percentage is the better for me, then I can use it. Okay, there is the no other thing about that, just showing the better satellite image or better view. But 98% is the great, there's no problem. Yeah. Okay, so filter metadata is only the minimize the cloud percent from the QA. We can remove the cloud. Okay, sometime, okay, I already discussed about that. Sometime you can also use the filter metadata. Suppose you want to need the satellite image for the coastal area, or you need to the satellite image for the river bank. You can put here the filter metadata 1% cloud cover, 1% less than 1% cloud cover is not available for your region. Then you have to increasing the value of the filter metadata, and when you increase the value of the filter cloud pixel percentage, then we can get the cloud. Okay, then we have to remove this cloud using this way, this I show you in this time. Okay, suppose 1% is not available, so that's why I increase the number of the cloud pixel percentage, and when I increase the number of the cloud pixel percentage, then my image will be cloudy. Okay, so then we need to apply this method and remove the cloud. But when you want to get the, you can use the 1% and your image is the not cloud, then you don't need to use this cloud max band function again. Okay, so it's only available when you can check the your image is not available for the 1%, you increase the cloud pixel percentage, and when you increase the value, then we can get the cloud. So this type of cloud we can remove using this function, cloud marksman function. Okay, so what does 1 kilometer indicate? So in this time, this 1 kilometer is that resolution of the pixel size. Okay, so 1 kilometer, also we can work with the 250 meter or 500 meter, 30 meter resolution. So it is the pixel size. Okay, pixel size, how many pixel size length, we can get the 1 kilometer. Okay, in this time 1000 meter. If you want to check this, you can see this data set. I want to check about the resolution of the data set is that 1000 meter or 1 kilometer. Okay, we can get the 30 meter, then it will be work for the 30 meter pixel size. In this time, when you want to work with this this data set, it will be work, it take the information from the 1000 meter area. Okay, it is the this resolution is not so good. Okay, so 1000 meter. So when this resolution, it will be low value identify the high resolution. Okay, low value of resolution identify the high resolution, but high resolution value identify the low resolution. Okay, so in, suppose 30 meter better than sentinel, 10 meter or 12 meter. Okay, so also we can get the different types of other satellite images for the 0.3 meter or 30 centimeter from the Maxar satellite image. So this type of high resolution satellite image we need to buy. Okay, and in this time it mentioned that the 1 kilometer means that 1000 meter pixel area. Okay, okay, so now I want to work with this data set and then try to make this LST map and also make the time series chart. Here you can see they already create the LST band. Okay, they already create this LST 1 kilometer band. Okay, they already create this band. So they already create the band. So in this time I don't need to create the band. I can directly make the chart. Okay, and this data set availability you can see from the 2000 from 2022. Okay, within this time I can get the, and this data set the every 8 day. So when I want to use the data set, I can get the image interval time period is the 8 days. Okay, so let's go. Simply copy that from here and paste here. Okay, then I simply give a variable name. You can use any variable name. So in this time I simply put the variable name, suppose for this LST. Okay, so in this time my collection is stored in this variable. Okay, so now I want to work with this data set, and in this time I also try to discuss about the new function, this function called the eDate and date range function. So two types of function I want to work. This is the new function, but if I want I can also ignore that, but I also give you the all of those function information, how you can easily work with that. So let's go about that. So first of all, I take a variable. Suppose in this variable I mention this date. Take a variable is the date. So when you want to define any date in Google Earth Engine platform, we need to use a function Earth Engine date. Okay, or I can simply put here the, suppose I mention here the start date. You can use any variable name. So I put the start date, and in this time I want to put my observation start date. So I put the time period, suppose year of 2015 1st January from here. So it will be start date my. Okay, in this time I want to create a date range function. Okay, I want to create a date range function and also got advance 1 year. Okay, or advance 5 year, or it's totally dependent on you. Suppose in this time I want to create a date range. So for that I create a variable name, suppose date range, and call a function dot date range function. Okay, and you can see the date range function is that 3 argument: start date, end date, and time zone. In this time here I already defined the start date, so I simply copy this start date and paste, and end date. In this time I want to put here the end date will be advance 1 year. Okay, so from start date, this is my start date. So from the start date I want to up advance 1 year. Okay, so for that I simply copy this start date, because I want to from this start date up to advance 1 year. So simply copy this same variable and use here, and use a function advance function. Advance. advance up to 1 year. Okay, so in this time here I put here the delta, mainly this is the numeric value, how much year you want to need. Suppose I need the 1 year, so put here the 1, and then unit is that year, so put here the unit is the year, so put here the unit is the year. Okay, and then remove that, it's not need, and it also not need. In this time what happened, you can see in this time when I want to put this type of range, here I can get the data set from 2015 January and also advance 1 year, so 2016 December. When I put here this advance 5 year, then it will be start from the 2015, then go to the 16, 17, 18, 19. From the 19 I can get this time year, this data set. Put the 10 year, it will be start from the 2015 and up to 10 year. Okay, suppose you want to need not for this year, you want to need the data set from the January and advance 10 year. From it will be start from the January and up to the advance 10 year, 10 month. Okay, so put here the month. So now we can get the this result will be start from the January, then go to the February, then March, April, and up to October, year of 2015. Suppose you want to need the result for the only 10 days, from it will be start from the 1st January and up to the 10 days. So then put here the day. Okay, so this is the topic how you can easily define your date trends. Suppose in this time I want to need the data set for the 2 year, so put here the 2 and put here the year. So in this time I can get the data set, it will be start from the 2015, then 15, 16, 17. Okay, it will be start from the 2015 and up to advance 2 year. Okay, so this is the function for the date range, and we can from the date range we can easily add here the advance our time period. It can be unit, can be year, it can be in month or day. Okay, so now I want to use that and try to make this. So for that I take a variable, suppose or LST, you can use any variable name, and from this image collection I want to select a band. So I simply use call this and use at the select function. Select, and I select this band. You can see this band is that LST 1 kilometer, and this unit is the Kelvin. Okay, we can easily change the Kelvin. Also you can see it has also a scale. So mainly we can get the scale for the MODIS satellite imagery. For when you can get this scale value, it means that this data set you need to reproject it, otherwise you did not get the proper result. So we already check about our MODIS NDVI. When I want to work, we also need to reproject our scale value. Okay, in this time I want to use this scale and then try to reproject it this scale value, as well as also change the unit. In this time it's showing the unit is the Kelvin, but I want to need the result in degrees Celsius. Okay, so let's go about that, how we can do that. So in this time I simply paste here this band LST 1 kilometer. Okay, so in this time I simply use here the filter date. Okay, so now we can guess it, what's the value I want to use here. Start and in. Anyone can guess it? What is the value for this start and in part? Okay, so in this time you can see here I define the start date and up to the advance 2 year. Okay, so this is my start date and this is my in date. Okay, and it is stored in a variable date range. Simply copy that and simply put in here. Okay, so now it's done. Date range is stored the start date as well as also in date. So now I want to show the result. So first of all, try to show the result. Suppose use at the map dot add layer and call the mode LST. Okay, and also click to the run. In this time we can get the result for the whole world. If you want, you can also add here this color plated from here. Suppose simply copy this color plated from here. And paste here. Simply copy that. And then paste after the object name. Click the run. Now it displays the result. You can see for the whole world. Land surface temperature map. Okay, where is the high temperature? We can easily identify. Okay, this type high temperature, and also give the low temperature for this region. Or island, you can say Iceland. Okay. So in this time, you want to check the value. You can check the value look like. You can see click on here. I can get the value look like this 15,978. It means that this result is not reprojected. Okay. So in this time, when I want to reproject this result, then I can get the accurate value. Okay. And also get change the unit. Basically, in this time, it's showing the Kelvin unit. This data set created in the Kelvin unit. You can see that already mentioned that Kelvin. So in this time, we can easily from the Kelvin, we can easily make the conversion in the degree Celsius. Okay. So let's go about that. How we can easily do that. For that, first of all, in this time, we need to create a function. And if you want to check how many images I want to got in here, simply use the print function. Print and call the mode LST and use the size function. "92 images we can got in here for the 2 year. Okay. In this time, I want to reproject all of those images, 92 images, as well as also convert their unit.